Oh, hi there. My name is Teja. I'm an application engineer for the MathWorks in the Tokyo, Japan office. So I got a great demo for you guys today. What we're going to do is basically solve a Sudoku puzzle just using a plain old USB webcam and, of course, MATLAB. So this is MATLAB, and I'm going to open up Sudoku video function here. So I'm just going to run it, and you can see that if I just point a Sudoku puzzle, like for example this puzzle here at the camera, once we lock onto the target there, you can see that I have the solution to the puzzle just in the matter of a few seconds. So how did I make this? Well, I think there's two steps involved here. So the first step is to actually have a Sudoku solver where you actually can carry out the Sudoku algorithm. So if you have the numbers for the puzzle, you can actually find the solution. That's the first step. And then there's also the image processing aspect to this problem, where I basically take a Sudoku image. Here I used an image from the MathWorks News and Notes, but you could have tried this with any Sudoku puzzle image. And I actually have to read in the numbers from the book into MATLAB. I'm going to open up another file here, my Sudoku solver. This is the actual part where I do the Sudoku algorithm, the actual numerical part of the demo. This program, my Sudoku solver, gets a file name as an input, basically reads in the numbers from that file, and then calls another file here, Sudoku solver. And if I just open this, this is where I actually have, in about 50 lines of code, an algorithm which will solve any Sudoku puzzle, provided that it has a solution. So let me just try out this my Sudoku solver, and you can see how it works. I'm going to open up another text file here, Sudoku puzzle 1. So you can see I have this Sudoku puzzle here, put in a text file, and where there are no numbers, I'm just using a 0 as a placeholder. I can call my Sudoku solver and give it Sudoku puzzle 1, and you can see that in less than a second it basically just reads in the file and then shows me the solution. What's special here is we actually read in these numbers using a image processing algorithm. So I'm going to show you that now. Here's sample process. So here I'm just going to, we'll leave the video for later, but we'll just work with one image and see how this image algorithm gets applied to just a single image. So I'm going to open up sample.bitmap, which is just this file here, just one frame of a image that I took from this camera. And we're going to basically apply a number of steps in series. So the first thing I'm going to do is crop the image by just taking out the middle region here, like this. And the next thing I'm going to do, I'm going to use a little bit of block processing to make this into a black and white image. And when I've done that, you can see that the general outline of the puzzle is clearly there, but there's also a lot of noise, basically from the lines that were not completely thresholded well. And also outside of the puzzle, there's a little bit of noise here. And I'm going to remove a lot of this, basically just by using a couple of commands that I have in the image processing toolbox. So I'll do that first, and you can see that most of these small little lines have disappeared. The next thing we need to do is actually find out in which rows and which columns have numbers and what numbers those are. And I'm going to start off by finding the quadrilateral that is actually enclosing this puzzle area here. And then once I have this, I'm going to identify all the objects, all the independent objects that are inside this quadrilateral. And so I've kind of given a little red circle that's covering all these objects here. Because we do know the corners of this quadrilateral, I can regenerate the original Sudoku grid. So I'm going to just use a plain old projective transform from my image processing toolbox to redraw the original grid based on what it should be from these four vertices. And when I do that, I can clearly see then in which row and which column I have numbers. Now the next thing I'm going to do is basically identify what numbers these actually are. I know that there are numbers, but I don't yet know which numbers they are. I'm actually just going to compare these numbers to template data that I had previously taken and stored. So if I compare these numbers to this template data, I can actually get what numbers are in which rows and which columns, and I can calculate the solution using my previous Sudoku solver that we had talked about earlier. So the next thing I need to do, or actually the final thing that I need to do, is take the solution and put it back on the original image. And the first thing I need to do that is generate an image of the solution. This is what I'm actually going to overlay onto the original image. So I can use the previous perspective transformation in reverse to do this. And when I do that, you can see that indeed I can map that previous image back onto the original image coming in from the camera. So now I just showed you how I did this using a single frame, but the nice thing about MATLAB is I can actually apply this in real time to data that I'm streaming through the web camera. So let's just take a look at that one more time and you can see how that works. So I'm going to open up Sudoku Video FN one more time, and when we run it, you can see that we can get the original result just like that by applying the image processing algorithms to real-time frames from the camera. So I'm just going to leave you with that today. If you're interested, go to mathworks.com for more information. Okay, thank you very much. Have a nice day.